All right. So hopefully you read the problem before you started this video here. All right. So depending on, if you're on the Earth, what they're saying here is that the angular size for the moon and the sun is pretty much the same. The distance from the Earth to the moon is 4 times 10 to the 5th kilometers, and the sun, it's 1.5 times 10 to the 8th kilometers, because obviously the sun is further away than the moon. The diameter of the moon, so we know that is 3,500 kilometers. And the question is, what's the approximate diameter of the sun? So they told us that the angular size, the theta, they told us that it's the same for both the Earth, both the moon and the sun, but they never actually told it to us. Okay, so we're going to set up a couple of different equations here. Well, actually, we're just going to set up the moon one first. So the moon is about 3,500 kilometers. That's the diameter of it. And so that's like our S. S equal R theta here. And the R is the distance, from the Earth to the moon. So that's going to be 4 times 10 to the 5th. But they never told us the theta here. They never told us that angle. All right. So we're going to use this equation to figure out the angle created between the Earth and the moon, and then we're going to use that angle on the sun as well. All right. So to solve this, we are going to divide both sides by 4 times 10 to the 5th. All right. 4 times 10 to the 5th. All right. So on this side they cancel. And over here, this is going to give us our angle, and it is going to be in radians. So got 3,500, 4 times 10 to the 5th. All right, 7 over 800. We could leave it as a fraction. I think I'm going to make that into a decimal. So 7 divided by 800. All right, so this is our angular size. All right, this is going to be our theta for the moon and for the sun. So 0.00875. 0.00875. That's our theta. All right. And now we're going to use this to set up our sun equation. All right, so S equals R theta. Now for the sun, we're solving for the S, because that's the diameter that we're solving for. The radius, which is like the distance from the Earth to the sun, is this 1.5 times 10 to the 8th. All right, so that's my R. And then our theta is going to be this number here. All right, and all we have to do is multiply those two, and that's going to give us our arc length, or the diameter of our sun. All right, so I have 1.5, 10 to the 8th, and we're going to multiply that by 0.00875. All right, so this is going to give us, 1312500. It's going to give us 1,312,500 kilometers, and that is the diameter across the sun. Wow, that is huge. All right, if we wanted to write that in scientific notation, it would be 1.3125 times 10 to the, would that be the 6th power? Let's see, 1, 2, 3, 4, 5, yep, times 10 to the 6th power. So that's our answers in kilometers. So a very large sun.